Hello everybody, welcome to our next video. This video is especially dedicated to one of my students, but basically it is for all of my students who I really love, and let's go. Our today's task is to sketch the graph of the function f, which is defined by the equation y equals 3 times absolute value of x plus 2 minus 3. In this video we will not use the linear absolute value function transformation. We already know how to do the transformation and how to sketch the graph, but this video is like get ready for more complex tasks and for sketching more complex functions where not only one absolute value will appear, but there can be 2, 3, 4 or how many absolute values you can think about. But then the graph and the procedure is becoming like more complex and quite time consuming. But just to show you what will be in my next or our next topics during our lessons, so we will be able and we will learn how to sketch the graph of the function which will be defined, for example, by the equation like this. Or the last one, let's say the hardest or the most complex we will talk about can be function given by this equation, and you will really see that we are also able to sketch the graph of any of these three functions based on the technique I'll show you today. Okay? So let me start. As I said during the lessons, the first thing or the first step you do when you try to sketch the graph of such a function, you find something which we called 0 point, or you can call it like key point or critical point, and the point can be found like you look for the information when the expression which is in the absolute value, which in our case is x plus 2, is equal to 0. I will explain later why this point is important and what is happening there. So our 0 point is if x plus 2 equals 0, and this is if and only if x is equal to negative 2. The next thing we said is to split the set of all real numbers based on this 0 point, like into in this case into two parts. But if there will be more absolute values, then there will be more 0 points, and they will split all the real numbers into more than two parts. But in this case, I said it's a good idea, especially at the very beginning when you are learning the procedure, and maybe later on as well when there will be more absolute values, to sketch the number line and to be sure and to become like really familiar and to realize that these 0 point splits real numbers into two intervals. And then you will use this information like in the third point, where you construct the table to find what this expression in absolute value or the whole absolute value will become when you are calculating the numbers out of that. So basically in the next step you sketch the table. As you can see from the step number 2, the number line or real numbers are split into two intervals. One is on the left side and the second one is on the right side of from -2. So basically our first interval goes from the negative infinity to -2, and the second one goes from -2 to the infinity. You asked me during the lesson why is it so that in the first interval number 2 is included and in the second interval it is not. It's just because you want to have the number -2 in one of them, and it really doesn't matter if you include -2 into the first interval or into the second interval. Basically you can imagine this table like these are all the real numbers less than -2. Here is -2, and then there comes numbers which are greater than -2. Now what we do is we look how the absolute value will behave on this interval and then how it behaves on this interval. What you do here is you take any number from interval -infinity to -2 and you evaluate the expression for your chosen number. The good and clever idea is to get any number, but you better not take -2, because if you will take -2 you will not get the information how the absolute value is defined then. So we take in this case -10, which means then that the expression x plus 2 for x being -10 will be evaluated like -10 plus 2, which equals to -8, and -8 is less than 0. So it means to find out the real value of absolute value, you are now supposed to use the expression, the opposite expression from the expression which is inside the absolute value. So basically it becomes to -x, -2. Where does it come from? As we said, that this must be opposite expression of the expression in absolute value. So opposite means you just put negative sign in front of the expression, and when you get rid of the parentheses it will become -x, -2. The same thing applies for the second interval. You take any number from this interval, and as I said, the clever idea is to find some like kind of fancy or nice number with which you can calculate or evaluate the expression. So the best idea would be to take number 0. So you are looking for the value of 0 plus 2, which is equal to, and in this case 2 is greater than 0, which means you can evaluate your absolute value on this interval, -2 to the infinity, like with the same expression which is in the absolute value. So it becomes like x plus 2. Now let me explain what was happening here. And the main idea behind this is that if you want to find what is the value of absolute value of any x, from the algebraic definition of absolute value we already know that absolute value of x can be equal to x if and only if x is greater or equal to 0. Okay? As I was explaining before, for example, if you take number 5, then it would mean that the absolute value of the 5 is number 5, which is our number given. And then the absolute value of x can be calculated or is defined like negative or opposite number of x if and only if x is less than 0. What basically this means, it means if you choose x being -4 and you want to evaluate absolute value of -5, it would mean that you calculate negative of -5, and as we already know, this is really number 5. Okay, so what was happening here, and why did we look for this kind of 0 point or key point? We are looking for the absolute value of x plus 2, and it can be again evaluated as x plus 2 if and only if x plus 2 is greater or equal 0. You can think about it like about kind of substitution. This expression can be substituted by, for example, not y is not good, a clever idea, but let's say z. So if z is positive, then the absolute value is equal to z, but in this case we are not using z, but the expression x plus 2. Okay, and the same as was applied above says that absolute value of x plus 2 is equal to negative x plus 2 if and only if x plus 2 is less than 0. Okay, so basically if you would solve this inequality, it would be x is greater or equal to -2. Okay, and if you would solve this inequality, it would say that x is less than -2. So our absolute value x plus 2 is defined like this expression if x is less than -2, and it equals to this expression if x is greater or equal to -2. So basically, instead of writing such let's say complicated thing, we use this table, and we use this key point or 0 point to really find out how to calculate the absolute value. Okay, so this is behind the scene thing, and the fourth point is to define the function for x's of one of these two intervals. So it would mean that our function for each x of from interval -infinity to -2, okay, will be defined by the equation y equals 3 times. And now what do? We replace this absolute value with the expression we found out that is representing our absolute value. So my equation of my function will be 3 times negative x, -2 in parentheses, minus 3. So again, this absolute value is replaced by this expression, because we know that for x from this interval, the value of absolute value will be found like this. Okay. Next, we do the same procedure for x being from the interval -2 to the infinity. So my function will be defined by the equation 3 times x plus 2, the same procedure as we did here, take away 3. But if you look at this, we can simplify both equations. So let me just make a little bit space here. So the first part will be, the first equation will be y equals 3 times negative x is negative 3x, 3 times -2 is -6, take away 3 is minus 9. So this is my first equation of how the function behaves on this interval. You will see later on why this is important, because when we will sketch the graph, you'll see what is happening. And in this case, if we simplify the equation, then it will become 3x, as this is plus 6, take away 3, it means 3x plus 3. So this is the second equation for my function, and it says how the function is behaving on this interval, and how to calculate the values if x are greater than -2, or if you want to on the right side of -2. So Having this information, we are now almost ready to sketch the graph. There is one more important thing if you want to start sketching the graph, and it is to find the coordinates for the 0 point. So in this case, we know that the x value is -2, and we now want to evaluate what is the value of our given function for x being -2. But as you can already see, and if you realize what is this 0 point telling me, it is and how it was constructed or found, it means that the expression in the absolute value will be equal to 0. So you can very easily see that if x is 0, then y, if x is -2, then its y coordinate is -3. If you want to, you can evaluate y equals 3 times 0, -2 plus 2 minus 3, which is 3 times, and -2 plus 2 is 0, and it doesn't matter if there is an absolute value. Take away 3, which means it is -3. So from this you can see that our 0 point coordinates are -2 and -3. Now we have all the information which is needed for sketching the graph. So basically now you sketch the xy plane. So here is my x-axis and here is my y axis. I'll start, and you start with sketching the point P, which is in -1, -2. Let me have -3. So, and here again -1, -2, and -3. Okay. So these are my numbers. I'll find where the point is situated. So it is here. So we already know that this is the point, and as I said during the lesson, this point is important as well in this case and in all the cases, because in this case the function will change its monotonicity, which means it will become from decreasing to increasing, or vice versa, from increasing to decreasing, as we already know how the graph of this function will look like. Okay, so let's find where the rest of, or how the rest of our graph is behaving, and let's sketch first this function, which is defined now on this interval, which basically says, and it is the information what is the domain of this function. Okay, so we already know that this is linear function, and we know as the parameter in front of x is -3, it means that we will be sketching the graph for all x's from -2 to the left side, and the function will be decreasing because there is -3 as the argument in front of x. So we could start sketching the graph like this, but we want to do it more precisely, which means, and you already know, to sketch the line, and the line is well defined if you know 2 points, and the easiest way again is to find the intercept with the y-axis. We already know to find the intercept with y-axis, it has the first coordinate 0, and the second one can be found very easily, and it is this coefficient. So it would be -9, -4, -5, -6, -7, -8, -9. So here is my -9, and to sketch the whole graph or the whole line for this linear function, we would do it this way. Okay, so this would be our graph. Let me just sketch it like dotted line, and you will understand why, because now the function, our function given at the beginning, is now behaving like this linear function on the interval from on the domain from the -∞ to -2. So we are now just interested in this part of the line. Okay, So this is the first part of my graph. And now you sketch the second part of the graph, which is this function, and this function is defined like for this axis, which basically means we look for the line or for the graph of the function which domain is from -2 to the right. So we already know that our graph will start again at the 0 point. We already see that the function will be increasing, and we know that the function should go this way. But we want to be again more, we want to sketch it more precisely. So we again look for the intercept with the y-axis, and again we use the same technique. So our intercept is the point with the coordinates 0 and 3. So I'm missing here 1, 2, 3 next point. So this is number 3, here is number 4, but I don't need anymore. So to sketch the graph, we should sketch it something like this, and the same procedure applies as before. We are interested only in this part of the graph. Okay, so this is how we sketch the graph, by using this technique, and all the information we have learned so far. Okay, so let me repeat. The first thing is to find the 0 point. Like, let's say it's x coordinate. Then you split all the real numbers into two intervals. In this case, the first interval is on the left side of the 0 point, and the second one is on the right side. So you solve it like for x being less than -2 here, and the same procedure here for x being more than -2. Then you find how the absolute value is defined for x's from this interval and then this interval. The next thing is you build your equations. Okay, the first one, the second one. You find the y coordinate of the 0 point or key point, and then you just sketch the point, and then you sketch the rest of your function. So this function is represented by this line, and this function is represented by this line. Okay, I think that's all, and I hope you'll enjoy it and you'll become familiar with this procedure. In my next video, I will try to show you how to sketch the graph if the function has like two absolute values in its equation. So thanks for watching, and see you during our next video. Bye.